The broadcast is now starting. All attendees are in listen-only mode.
Hey everybody, welcome back to Amazing Mechatronics, and well, also Young Engineers of today. We're going to continue with Arduino today. I hope you all had a good couple of days, and I hope you're ready to learn some more, because that's what we're going to do. We're actually going to get started on the circuit and the programming today, so you don't have to listen as much to me just sort of yell at you through the internet. So if you have your Redboards and your SparkFun kits and stuff like that available, go ahead and grab them. Otherwise, if you're going to be using circuits.io like I am, go ahead and get started up on that, or 123D Circuits, same thing, circuits.io. Go ahead and get that started. And once you've either got your Arduino and your SparkFun kit in front of you and ready to go, or you're logged in on 123D Circuits, once you've done that, go ahead and raise your hand. Interesting. That is unusual. Oh, it might not be. Oh, no, I've. Yep. Well, what do you know? I may have just learned something new. Huh. Man, there have been so many movements and migrations for all this stuff. All right, so it looks like instead of circuits.io, it's going to be Tinkercad. Oh boy, never a dull moment. So apologies for that. Oh, come on. Aha, okay. So it looks like it's no longer circuits.io for those of you who are using that. It's going to be tinkercad.com. You'll be able to log in with the same login you created on circuits.io. I do apologize for the confusion though. Um, so yeah, I guess I will adjust that. If you are using Tinkercad, then raise your hand once you've gotten logged in. If you're using your SparkFun kit, your physical SparkFun kit, then raise your hand once you've got that in front of you and you're ready to go. All right. Got a number of hands. We'll just wait for a couple more. Perfect. Okay. So that's just about everybody. Let's go ahead and get ourselves started. I'm going to create a new circuit. So I'm going to hide all this business real quick. I can't hide all this business. Okay, yeah, here's an LED. Perfect. And a resistor. All right, come on. Work with me here. Okay, there we go. So this is the this is what circuits.io looked like. This is what Tinkercad looks like now. It's all pretty straightforward. So this big area right here is going to be where I'm editing my circuit, where you will be too if you're using this. Then I've also got a code editor and components and stuff like that. So this is where I can pull in new components. I'll explain the components so that if you're working on it at home, you'll be able to do that as well. And then when we get to the part where we're going to start with the code editor, I am going to tell you guys how to get the Arduino software and how to get it plugged in, because that's going to be a fair amount of effort in and of itself. Because Arduinos are not really cooperative, is the polite way of putting it. They can be a real pain to get talking to a computer, but once they do, then things should be okay. Then you can start pushing some code out to it and doing all sorts of crazy Arduino stuff. But as it stands for now, we're gonna wire up the circuit first, and then we're gonna worry about getting the Arduino communicating with the computer, which seems a little backwards, but I want to at least get a little bit of this done today. All right, so here we go. What I'm going to do is I'm going to get the things that I need. So the things that I need are going to be a breadboard. So you're going to need a breadboard at home. Then I'm going to need a single LED. I'm going to need a resistor, and it's going to be a 330 ohm resistor. And I believe your little bags of resistors should be labeled. If they're not, one of your sort of groups of resistors should have 2 orange bands and a brown band on it. That is going to be the 330 ohm resistor. I believe the other one has like a red band and a black band and some other stuff, maybe. Anyway, that's not your 330 ohm resistor. You want the orange, brown. So we've got LED, resistor, breadboard, Arduino, or breadboard, and just a whole bunch of jumper wires, because, why not? All right, for those of you following along with Tinkercad at home, that'll be a little bit of the controls. You can click on something to select it. It's got a blue outline around it when it's selected. You can type R to rotate it. You can hold down Shift and hit R to rotate it in the other direction. Exciting, I know. Anything that you have selected will come up here with a little properties window, which you can change the properties. So I can make this, for instance, an orange LED. Yes, hold back your enthusiasm. For instance, though, I can do such things as change the resistance of the resistor through that properties window, which actually is useful. So I just typed in 330 in the little drop-down menu. I selected ohms, which is the little omega-looking thing. You've got pico ohms, nano ohms, micro ohms, milli ohms, ohms, kilo ohms, mega ohms, and giga ohms. Giga ohms are for some serious resistance, but we're just going for regular ohms. So 330 ohms on your little resistor. The resistor will also change colors in order to reflect that. So, orange, orange, brown. And anytime you want to create a jumper connection between two things, as you can see, I can mouse over any of this stuff and it gets like a little sort of indicator there. Anytime you want to create a connection, you just mouse over one of these little red square areas and you click and you pull the mouse away. You click, you don't need to click and drag, and you will get a jumper cable, and then a jumper wire, and then you can connect it to something else. And in case you screw it up, you can hit the delete key in order to get rid of something. Make sure it's selected first, hit the delete key on your keyboard or the backspace key, and it'll go away. Undo and redo are up here on the top. Those are your best friends in life in general. So in any case, if you accidentally delete something or move something or do something, you can just hit the undo button and it's like it never happened, which is why it's so amazing. You can hit the redo button in case you undid something that you didn't mean to undo, in which case you can get it back. So redo is an undo for undo. It's just undos all the way down. So yes, these are actually all of the components we're going to have. We're going to have our breadboard, we're going to have our Arduino, and we're going to have an LED and a resistor. Arg. Notice how this Arduino is blue. If you get the SparkFun Inventors Kit, you're going to have a red one. Don't worry, they're the same thing. The SparkFun Inventors Kit Arduino, the red board, is literally just an Arduino Uno that's been painted a different color and has a different brand on it. I mean, more or less. It's got the same functionality. It's got a couple of extra things, but it's got the same functionality otherwise, and it's got the same power. So don't sweat it that I'm using something that looks different here. What you've got is definitely kosher, 100%. All right, so let us commence building our circuit. All right, so what we need is, let's check our schematic. We need an LED hooked up to a power source, hooked up to a resistor, hooked up to a power source. Wait, hooked up to an LED. Hooked up to a power source, hooked up to a resistor, hooked up to a LED. Yep, I remember the leg bone is connected to the LED bone. But that's it. This is a very, very simple circuit. That's all we're doing. So let me pull up the schematic here, the other schematic. Here's the useful thing. Our Arduino is going to act as power and as ground. So what we can do is we can go ahead and draw from our power over to our breadboard. And I can click on it and I can set the color of the wire. So I can set it to be red. And that way I can actually connect the breadboard to the Arduino. I can also connect this to the grounds and I will make that black. So now we've got a black and a red wire. Now you might be like, oh wow, that's interesting. He's color coded these. That is, well, convention. It's convention, essentially. Anytime you're looking at wires and stuff like that, you want to keep some consistency with it because one of these wires is not like the other one. One of these wires just zaps you a lot. So we try and keep track of that with color-coded wires. Red in this case is going to mean a hot wire. It's going to mean it's one that's got electricity flowing through it, and it's going to be one that's got the bad, angry zappies. Black is going to mean a ground wire, which is generally pretty safe to touch, although you don't want to touch that along with the hot wire. You definitely don't want to touch those together. You'll definitely want to avoid touching the hot wire, and you'll definitely want to avoid touching the hot wire and the ground wire at the same time, because then bad things happen. This convention is used in a lot of places. So like, for instance, if you end up wiring your home, you'll find that the color of the wires in the house will also be color-coded. And unfortunately, they can't really decide on a consistent color coding for housing wires. That'll change depending upon when your house was built, and that's all just super annoying. But generally, green is ground, and either white or black is hot, but sometimes black can be ground. It's at least, that was a house that I helped out on. That wasn't great. Regardless, point is, I'm doing this for aesthetic reasons to help keep track of things more easily, which is also another valid reason to use colored wires. But it's important to note that the colors themselves can sometimes mean something important. So anyway, enough of me rambling on about things. Let's go ahead and build this circuit. So as you can see, we got the power running from the red board to the LED, to the resistor, to the ground. They're all labeled as such, so that's how we know. So I'm going to take my LED and I'm going to rotate it. So now it is plugged in. Notice how it's straddling two buses. This is so that we don't short circuit things, because short circuiting things is bad and that's how fire happens. So we're going to avoid that because we like fire in a controlled way, mainly, as humans. So we're just going to stick that right there. Perfect, good to go. Then we're going to have the resistor actually hooked up to the LED. So let's see here. Cathode and anode. As you can see, the anode is the plus on the LED and the cathode is the minus. The cathode is the shorter leg. So the cathode is the shorter leg. That's another easy way to remember that. We're going to plug in the resistor to the same bus as the one with the cathode, the shorter leg. We want the shorter leg to be plugged into the same bus as the resistor. And then the anode, the longer leg, is going to be plugged into the power. So I'll just run a wire from here to here. I'll actually move this over so that you can tell more easily that it's moved, and I'll make it a nice orange color. So you can see we got the power plugged into the resistor, or excuse me, the LED. Good Lord, terminology, don't mix it up. Power plugged into the LED. Then we've got, because this is on the same bus as the power that's coming in from the Arduino. Then we've got the resistor, the other end of the resistor, because notice it's on two separate buses as well. One of those buses just happens to be shared with the LED. This is going to be plugged in to ground, and we're going to make that gray. So now there's sort of like modified versions of what we got. So we got the red wire going to power, and then from power over the orange wire to the LED, and then the LED to the resistor, to the gray wire to ground, to the black wire to ground. And that should be our circuit. We can actually double check this by taking, instead of from pin 13 on the Arduino, we can plug it into the 3.3 or the 5 volt and hit start simulation. And we'll see that the LED will light up of its own accord. If you guys try this at home, maybe plug it into the 3.3 volt. Although the 5 volt should still work. So if you plug it into the 3.3 volt, you'll always be getting power to the LED, so the LED will always remain on. And that's because that particular pin on the LED is meant to always provide power no matter what, forever and ever and ever. Pin 13 here, this one is going to be the one where we use a little programming magic in order to make it turn on and off whenever we want it to. So guess what? We have wired our Arduino. Next step is we are going to, words make words, we are going to plug in your Arduino and get it to talk to your computer. Oh boy, here comes the fun bits. Get ready. So if I open up a new tab in the Google and I type in Arduino, first result I get is arduino.cc, which is Arduino's website. we can go ahead and click on that. And we get Arduino's website. And then you get to see the sweet nunchuck clock. That's interesting. And just a whole bunch of stuff for Arduino. I mean, as you can see, they're sort of showcasing all the different projects that people might use Arduino for. RoboGlove assists users with gripping objects. That's kind of neato. Arduino Uno, Mega, MKR, Zero, just all kinds of stuff. What we're going to do is once we're here, we're going to click on Software at the top. Oh, well, that's new, the online IDE. We're not going to mess with that because we need to worry about getting this talking to your computer. So what we're going to do is we're going to come down here to the boring non-internet IDE, and we're going to select the operating system. I was going to say of choice, but you should select the one that you're running. So I would select the Windows installer. If you're not sure whether or not you have admin privileges, you would select the zip file for non-admin install. You could do the Windows app, although, or you could do Mac OS 10, 10.7 Lion or newer, or Linux 32 or 64-bit or ARM. But if you're like me, you're just going to be going with the Windows installer, and you're going to get this thing with adorable little, components that are all holding hands, and they want you to donate money. We're all pretty poor here, so I wish I could, but I'm just going to download. And after feeling a little bit guilty about that, my download starts. We'll give that a couple of minutes. Okie dokie. And after that exciting little waiting period, I'm just going to go ahead and install. Hit I agree. We're going to install the Arduino software, the USB driver, and we're going to want to associate INO files, but, well, maybe. You can keep all this stuff checked. It's not life or death, but, excuse me, at the very least, you'll want to install the Arduino software and install the USB driver. Those are definitely paramount. So I'm going to click Next, and then it's going to suggest an install location, and I'm going to click Install, and then it's going to install, and everybody's going to have a wild time while we watch the progress bar go up. Woody woo. So here's the dealio. I want to put everybody's hands down. Raise your hand if you have a Mac. Okay. Raise your hand if you have a Linux computer. Some flavor. All right, so we got one Mac hand. All right, so we might run into a situation in which you need a special download in order to get to communicate with your computer. Keyword being might. Not necessarily, and I'm really crossing my fingers that you won't, because it'll make life so much easier. But regardless, just keep that in mind. Otherwise, by and large, I think the ARM processors are okay. AMD, excuse me. Why did I say ARM? AMD processors are okay. And Intel should be definitely fine. I'm thinking out loud here. Because I know in years past we've run into some pretty significant issues with getting it installed because there's essentially a little translator that you had to download, different from the driver. But I'm thinking that they probably got their life together since then, and you won't need to do that. At least I would hope so, because it's been 3 years. Anyway, yep. It's also helpful to think out loud just because it sort of fills the time while this thing is installing. For those of you who are installing, go ahead and raise your hand once it's done installing and you've gotten it open. For those of you who are not installing, just go ahead and raise your hand. Like if you're just running off of Tinkercad. Oh, fantastic. Okay, so that makes it easier too. Would you like to install this device software? Yeah, generally, install. Always trust software from Adafruit Industries. I'm going to uncheck that just because I don't install things from them often. And you never know. Always trust software from Arduino SRL. Same deal. Your call. If you feel confident with it, yeah, I'm going to trust software from Arduino LSC. If you feel confident in it, then go ahead. Okay, fine. Yeah, I'm going to always trust from Arduino SRL. Otherwise, you're not required to. I'm not the computer police. I'm not going to make you agree or not agree to anything like that. Which, I mean, regular police wouldn't do that either. But, you know, whatever. All right, so I went ahead and got it started up. Looks like you guys are all further along than me. So, here's the thing. Here. You're going to need to plug your Arduino in, but don't do it yet. I do this just to mess with people. All right, what we want to do is we want to go up to Tools, and you want to make sure that your board is an Arduino Genuino? What? That sounds so fake. Uno. You want to make sure it's an Uno, regardless. So it's definitely got to be an Uno. And then mouse over the port and take note of what serial ports there are. Chances are you're only going to have like maybe 1 or 2 serial ports. In my case, I only have COM1. Cool. Note it, check it, good to go. Now, close the Tools drop-down and plug in your Arduino. Once your Arduino is plugged in, yes, this will work with the breadboard. The breadboard is Arduino, so it'll 100% work with that. Like it's like if you took a Ford and you painted Mazda on it. Not even. It's like if you took a Ford and you painted Apple on it, and it was like the official Apple car. It's still a Ford, and Ford dealerships could work on it and stuff like that. It's got Apple logos and stuff emblazoned on it. But yeah, so plug in your Arduino, and once it is plugged in, go back to Tools and check out your ports. And you should, hopefully, see new ports there. Once the computer's done like checking for drivers online and stuff like that, like it likes to do, and I go like, oh hey, I know what this is, ha ha ha. Check out your ports under the Tools window. Whatever new port appears, if a new port appears, fantastic, wonderful. That is going to be your Arduino's port. Select that port, and you should be off to the races. If not, maybe give it a minute. And after a minute, if it still doesn't, then maybe it'll be connecting on COM1. Not likely necessarily, but potentially. And I'll give everybody like 2 or 3 minutes just to sort of dink around with that. Because that can sometimes take a minute. And then once that's done, we'll get started with the programming aspect of it. Okie dokie. Anybody run into any issues with that little process? We'll know for certain once we send some code to the Arduino, which we can actually do right now as I walk through the different stuff that's here. So, when you first open the Arduino program, you automatically got this sketch. And it's a blank sketch, although it doesn't look like it. It's got a couple of little functions here, so a couple of names and some curly brackets, and then it's got a couple of comments, that is to say some plain English stuff with some slashes in front of it. The void setup with the set of curly brackets and the void loop with the set of curly brackets are basically the two things that are necessary in every single Arduino program ever. You can add more, but you can't have less than those two. You gotta have those two, and they gotta be labeled that, and they gotta look like this. with the void setup and then the parentheses and then the curly bracket, and at least a closing curly bracket for it somewhere, and then a void loop with the open and close parentheses and the open and close curly bracket. Those are things that are necessary. However, this is, being that it's the bare minimum that's necessary in order for an Arduino to run, you can actually upload this to your Arduino. It's not going to do anything interesting, but you could totally do it. So if you just click this little arrow right here labeled upload, what it's going to do is it's going to verify your code for you, which is what this check mark does. If you click the check mark, it goes, oh, hey, let me make sure that all your code looks good. So what it does is it interprets all the code, does a little essentially programming spell check, spell and grammar check to make sure everything looks okay. And then it says, hey, Sketch uses 444 bytes of program storage space, maximum is 32,256, and global variables use 9 bytes of dynamic memory, leaving 2,039 bytes for local variables, maximum is 2048. So it's got 2 meg of dynamic memory and 32 meg of storage space. Learning new things. Anyway, what verify does is it's like a grammar and spell check for your code, and you need to pass that before you can upload your code to an Arduino, because otherwise your Arduino freaks out and goes on the fritz and everybody's sad and it's all unhappy. Upload will verify the code, then assuming that it verifies, will connect to the Arduino and transfer everything over the USB cable to the Arduino, so it suddenly has whatever program you've just written. Then you've got new, which will open up a new sketch, open, which will open up a saved sketch, save, which will save a sketch, and the serial monitor, which is an interesting little thing that we will get into in future classes. But it's actually a very, very useful little debug tool and just sort of do generally cool things tool. With that in mind, go ahead and click on the upload button and see if you don't get any angry red or orange. I'm going to get some angry orange because I do not have an Arduino plugged in. Mine is going to sit here forever trying to communicate along the COM port, but it can't. And eventually it will give up. Eventually it will give up. Work with me here, Arduino. La 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 la. La 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 la. Yep, there we go. Hey, finally. All right, problem uploading to board. AVR dude, STK 500 received, programmer is not responding. AVR dude, STK 500 get sync, attempt 10 of 10, not in sync, responded 0x6c, which is hexadecimal. Ooh, exciting. So really, this is what I was looking for. If you get this and you do have an Arduino plugged in, that's not ideal. What these errors mean is they mean that the Arduino is not communicating with the computer. Fine in my case, because I don't have an Arduino plugged in. Less fine in yours if you do have an Arduino plugged in. So if anybody gets that, just go ahead and mention it in the question box, and we can see what other troubleshooting tricks we can utilize. I'm really hoping not, though, because it's been a couple of years since I've done Arduino and I totally have forgotten all of my special tricks. Which, man, would my face be red if I had to look a bunch of this stuff up. Anyway, so yeah, attempt 9 out of 10, as you can see, it attempted a whole bunch of times. It's, What I'm going to do is I'm actually going to type the code in here, though, because I can make the code big and readable. I'm going to change the font size from 12 to 24, so we can say hello there. And I'm also not going to delete the void setup and void loop because we kind of need that. So we're looking at some blank code here. What we need to do is we need to set up our Arduino so that it knows that pin 13 is an output pin, and it actually sends electrical current out on pin 13 and on a regular interval so that our LED blinks. So let's go ahead and let's check out some of the code really quickly because it's 8:42. Okay, here we go. That just took a second. So this is what the final code looks like. Int LED pin 13, void setup, pin mode, LED pin output, void loop, digital write, LED pin high, delay 1000, digital write, LED pin low, delay 1000. Whoa, whoa, there's a whole bunch of new stuff there. Fear not, for I am here to yell at you for the next 10 minutes as I walk through this until it all makes sense. Because yelling makes things easier to understand. All right, so first things first. I got this little line of code that is int space LED capital PIN, all one word, LED pin that is, space equals space 13 and then a semicolon. So we've got int LED pin equals 13. What exactly is going on here? Well, what we're doing is we're saying that there is a specific part in memory. We're telling the Arduino that there's a specific part in memory that we want to hold on to a value. That's called a variable. You can think of it like a box where you hold stuff like thoughts in, if you could hold thoughts in boxes. Really poor analogy, like shoes. You might have different boxes with different shoes in them, and you might move the shoes around from box to box. You might mix and match shoes and stuff like that if you really wanted to, I don't know, mess with people. Point being, those boxes hold these shoes and they can hold whatever kinds of shoes you want. You could label that box Nike and have Adidas shoes in it, and it wouldn't be helpful. But, you know, you would, or you could label the box My Shoes and have maybe Nike shoes, maybe Adidas shoes, maybe New Balance shoes, maybe Birkenstocks, maybe, you know, whatever. Crocs. Anyway, and you could have like, you know, my sister's shoes or my brother's shoes, and that other box is labeled that, and they could have different shoes in them. This is sort of the basis of a variable, and I feel like that's a little bit simpler than it needed to be. It's like a math variable. It's you have the ability to hold a value in something that's given a name that means something to you. So what we're doing is we're holding the value 13 in a variable that has a name that means something to us. In this case, LED pin. This int in front of it means that it is an integer variable or a whole number. So what we're doing is we're saying, hey, here comes an integer variable. It's going to be called LED pin, and I want you to make it equal to 13. And then the semicolon on the end is, think of it like the period at the end of a sentence. Any really, like any statement that you make in programming in the Arduino language, is going to end in a semicolon. These are not statements, so they do not end in semicolons. But this one is, so it does end in a semicolon. That'll make a little bit more sense later. I also know that I'm not walking through this in the most intuitive way, just because I realized that we're so short on time all of a sudden. And I have nobody to blame for that but me. So int LED pin equals 13. We're creating a whole number variable called LED pin holding the value 13. Perfect. Next, what we want to do is we want to set up the pin, because this doesn't intrinsically mean anything. We called it LED pin, but that's simply so that we can keep track of it. But the computer doesn't know that LED pin necessarily means anything. We could have called this bobble, and then we can reference it as bobble from here on out, and it would know that we meant the number 13. You could think of it almost as like an alias for the number 13, or like an alternate name, except then we could change the number as well. So we're going to keep this as LED pin because it's good programming practice to have useful names for your things, not like bobble, unless bobble happened to be a useful name, in which case that would be wicked fun. I want to write a program now where bobble is actually a useful variable name. So now we need to actually set up the pin on the Arduino, and that is done with the pin mode call. What this is doing is it's saying, hey, Arduino, we're going to set up a pin to do a specific thing, and the Arduino needs two things from us. It needs, hey, what pin and what are you doing with it? Are you making an input or an output? So we answer that inside of the parentheses. So it's got to be pin mode, all one word, PIN with a capital M, ODE, then open and close parentheses and a semicolon. Inside the semicolon, we're going to put LED pin and then a comma and then output. So here we are, we've fed the two things that the Arduino asks of us. With pin mode, it needs the pin and whether or not it's going to be input or output. Well, here we've got the pin and we've got output, because remember, we've got everything hooked up to pin 13. Perfect. So void setup, pin mode, LED pin, output. So far, so good. We've initialized a variable called LED pin. We filled it with the value 13. And we've used it in lieu of actually writing 13 here because we like to type more. It's also for labeling purposes. It's helpful for that. But we've used it here to tell the Arduino, hey, pin 13 is going to be an output pin. Now, we need to turn it on. And then because computers are dumb, we need to tell it to turn back off. And this is done with a call to something called digital write. DIGITAL, capital W, RITE, digital write. Digital because we're using the digital pins, as in pin 13, if you remember that explanation from Tuesday. And then a write because we're saying, hey, we're sending stuff out on that pin. Even if we're telling it to stop sending stuff out on that pin. Yeah, even if we're telling it to stop sending stuff out on that pin, that's still considered a write function. We're just ending the write function. So here we've got digital writes. And we're going to say LED pin because remember, the Arduino needs two things. It needs what pin and are we turning it on or off? LED pin high and LED pin low. What do high and low mean? Well, high and low are synonymous with on and off for a lot of digital things. All we're saying here is turn on and then turn off and then turn on and then turn off. And where did I get the idea that it was going over and over again? Well, I'm glad you asked. I got that from the fact that this is the void loop. See, this is the way that the Arduino is structured. All of its programs, you always need a void setup and you always need a void loop. And the way that an Arduino always runs is it always runs the void setup once. The void setup gets all its ducks in a row, gets everything ready for the next part to come, which is the void loop. And then the void loop, as long as the Arduino has power, will run over and over and over and over and over, and you get the idea. So it's sort of it's well it's an endless loop. It's an infinite loop, but it's intentionally designed to be that way. This is the whole idea behind the Arduino. So you can keep the Arduino plugged in for minutes, hours, days, weeks, months, years, maybe, um, and have it still do the same thing always for that entire time. It will always do the same thing until you reset the Arduino or you unplug it and you plug it back in or you upload it with new code. In which case, the first two things, if you reset it or unplug it and plug it back in, it will run through the void setup again once, and then it will run through the void loop again over and over again like nothing ever happened. Or if you upload a new program, it will run through that program's void setup once, and then it will run through that program's void loop over and over again. This is the only thing that the Arduino does at its base. Now, you can do all kinds of crazy complex things in setup and loop. And that's where the Arduino's functionality really starts to shine. But at its base, at its core, void setup always runs once. Void loop always runs always, forever after void setup. So that's how I know that this would be running like this, and then this, and then this, and then this, and then this, and so on and so forth. Because that's just how the Arduino is structured. Now, this is all well and good. However, this is going to be a little bit crazy. So what we're going to do, instead of just having it turn on and off, is we're going to have it hang out for a second. And yes, I just overpronounced the G in hang. By using a delay function. So now delay does one thing and one thing only. It delays running the program by a specific number of milliseconds. And delay needs one thing. Delay needs how many milliseconds it's going to delay for. So we're going to get it up. Wow. Okay, let me try that sentence again. So we're going to give delay what it wants. Just throwing in the parentheses here, I can do 1,000. And if we're dealing in milliseconds, how long is that? I mean, that's pretty straightforward, right? Oh, I'll just go ahead and spoil it. It's a second. It's one whole second. Milliseconds are thousandths of a second. So if we delay for 1,000 milliseconds, we are delaying for a whole entire second. And with this, we have actually created our first program. Now, if we run through it, we'll set up an integer, a variable, an integer variable, call the LED pin, fill it with the value 13, then we'll go into void setup. We'll set LED pin 13, to be output. Then we'll go into void loop. We'll turn on LED pin 13. We'll delay a second, so it'll be on for a second. Then we'll turn LED pin 13 off. Then it will delay for a second. And then it will go back up to the top. And then we'll turn it on, wait for a second, turn it off, wait for a second. You get the idea. Go ahead and upload this to your Arduino and majesty at the blinding brilliance. Marvel at the blinding brilliance of your new little circuit. I don't know why I said majesty. I think I was trying to say it the majesty and blinding brilliance, but whatever. I'm just trying to be too clever for my own good. I can't words. Anyway, go ahead and click the upload button, or if you were typing it into, hold on while I cough. If you were typing it into the code editor here, ooh, wow, they use Scratch. Okay. Go ahead and click upload and run, and then you will see your Arduino send a signal to the LED to cause it to blink. Hey, awesome. All right, with that in mind, that's going to do it for today. So what I'm going to do is I'm going to go ahead and give the poll questions out. If you have any questions about what we just went over today, and I imagine there will probably be a couple, and that's nothing against you guys, it's just because this is A lot of stuff to tackle on the first real day of actually doing this stuff. Um, I'll be here after the poll questions to answer those for you. Otherwise, if you answer the poll questions and you don't have any questions of your own, you're more than welcome to head out and have a wonderful weekend, and we will see you on Tuesday where we do more Arduino stuff.